Good morning, ladies and gentlemen, and welcome to today's session. I am Crystal Gail Williams, Marketing Officer at Fujitsu Caribbean, and I am based in the Jamaica office. We're happy to have you join our Tech Expert Hour, where we will help you understand the capabilities, features, and business benefits of Azure, Data Factory, and machine learning. First, let's go over some housekeeping matters. So today's session is being recorded. The duration is an hour, and we do encourage you to post questions. We do have an allotment made for your questions, and our presenter will feed those questions and provide you with some responses. You are all in listen-only mode, but as I said, you can use the Q&A feature to pose your questions at any time during the session, but we will tackle those during the question and answer portion. You will have access to the recording at the end of today's session, and you can share that with your colleagues, your networks, and perhaps watch that again if you so desire. All right, so to kick off today's session, I want to share with you that where there's data, there is value. And one of the best strategic assets that a company has is the data. You have data on your markets, you have data on your customers, assets, and processes. It can help you make better decisions that can put you ahead of your competitors. It can give you a window into the evolving markets and your customers' behaviors. And it can show you how to save money with more efficient processes. For today's session, we have a professional data scientist, data engineer, who strongly believes in the concept of data is the new oil. He possesses a wide array of skill sets and domain knowledge in business intelligence, security, loan services, sales, chemistry, and marine biology. These skill sets, coupled with data engineering and analytic techniques, allows him to bridge the gap between ambiguity and intelligent decision making when leveraging the cloud. Ladies and gentlemen, your presenter for today, Jermaine Samuels. Over to you, Jermaine.
Thank you so much for that, Crystal, and good morning to everyone. Again, my name is Jermaine Samuels, and today I'll be presenting on Azure Data Factory and machine learning. Okay, great. So again, this is a Tech Expert Hour, and we'll be talking about some key concepts that are actually important for cloud computing as well as business intelligence, how we get the data orchestrated, and we feed that to our machine learning models so that we can make those important insights that we need for business intelligence. So let us start off with some of the key concepts that we'll cover, or why is it important to actually implement the cloud and business intelligence. So some of these things include delivering the right information, and it doesn't just stop there. Delivering the right information to the right destination on time is also an important asset. Cloud computing inadvertently provides convenient ways to access BI applications, so much so that the application that we'll be talking about today we'll be able to showcase how that integrated various mobile devices, or we'll talk about some of that, but we'll focus mainly on the functionality aspect. Also, cloud allows us to access these particular features on multiple devices and browsers, and it basically circumvents on-premise limitations, where currently, traditionally, there are situations where we develop our reports from in-house. We have special persons going in and making these reports or doing the uploads or various updates in order to actually make those important insights. So it's important to actually look at cloud as a viable option to move away from traditional methods and look into new ways of actually getting information in real time. Business intelligence improves with AI. What exactly does this mean? As Crystal said before, we can actually create value from data, where we can actually access real-time insights, make happier customers, build competitive advantage, improves efficiency, and access untapped value from data silos. So we know that at the moment, there are various challenges that businesses face. And with this presentation, we'll be looking at some of that. But just to start off with looking at some of the traditional methods, currently, what we've seen in the market is that we actually engage in descriptive analytics, where we describe what happened in the past with data, and from that we make a broad analysis as to what we need to do in the future, right? Now, the other aspect is moving a little bit away from traditional methods. We're saying we need to employ diagnostic analytics. This is talking about what has actually happened in the past and how we can actually move away from that into creating a solution that best fits the company. Again, we look at possibly different groups of customers, but this is where it gets really interesting. When we move into predictive analytics, we're talking about what will happen in the future. If you probably realize some of your applications that you have now, maybe Netflix, even Amazon, you may receive some notifications about what you can actually use or what you can actually buy if you're using that application. And that's because they're analyzing your trends using AI. And from that, that will roll into prescriptive analytics. Now that we have the data, what exactly are we going to do? How relevant is that to our company? So now that we know that this is going to happen in the future, prescriptive analytics will allow us to actually make important decisions that will move away from the traditional methods of just looking at what has happened in the past and allow us to make decisions intelligently. There are other aspects that we need to talk about as well, and that is cognitive analytics. This is referring to when we need to pull data from unstructured data. And when I say unstructured data, that's talking about some features like maybe you have some natural language processing that you need to do. Maybe you have some files that you've scanned and you've stored them away in silos. So that's where we're talking about access to untapped value from data. So you may have these physical documents and you really can't read them by yourself or have 100 persons reading these documents. So it's important to maybe implement an AI to actually read some of these. So that's what we call cognitive analytics, where we use machine learning to do automated things that human beings would have normally been required to do, or we can analyze images or even audio files. Getting value from data is not easy. And when I say that, I'm not saying that with any insignificance. Basically, most companies report struggling to become mature data users. Again, this is mainly because some of the process to actually look at all your data is a laborious process. It would take a lot of staff members and a lot of resources to actually get information that you need from data. And again, some of them report that data silos and data management difficulties are roadblocks. Again, that's speaking to resources and difficulties accessing the value from that data, because even if we do find out what is happening in the data, we'll still need to perform some analysis to be able to actually improve or add some intelligent decision making to make the business more profitable or more productive. So let's outline some of these business challenges. Many companies have a wide array or range of different problems that they want to solve. And it could be that they just want to increase revenue. Perhaps they want to improve customer experience, improve profitability, reduce customer churn, understanding the true value of archives of data, and maybe they want to automate some of their reports because they really have someone in our office who's manually doing these reports, which takes a lot of time. And as a result, the ripple effect is that other departments are impacted negatively because these reports are not coming on time or they are prone to human errors. So let's look a little bit at the value of business intelligence. All right. So we're talking about business intelligence value, right? Now we're saying that as the amount of data increases, so does the business value. We also can look at the historical progress of this, or the traditional method, which would be mostly related to historic value as to what has happened in the past. But then when we're going to be building our models or talking about how we can improve making recommendations, we need to identify relationships. And this actually points out different data silos or different databases that are probably not at one location for a company. You may have different branches. And as a result, you don't see the relevance of accumulating all the data to look at important insights. So this is where business intelligence will be improved with AI. Now, this is a quick example as to exactly what we're talking about. When we talk about business intelligence and business intelligence prediction, that's mostly related to traditional methods where you look at your historical data and you probably group some of your customers. So let's take a look at this where we see business intelligence. You can actually see that 7% of your subscription canceled in 2019. So you pull down your data and you actually see that out of 100 customers, 7 of them canceled. Then, based on that, you could possibly do some analysis and say, okay, based on this, we can predict or we see that 10% of customers will cancel in 2020, right? Now, things become more diverse or more significant when we move into the AI aspect of it, which is the predictive analytics. From doing our regular way of looking at business intelligence, we can move into looking at a specific customer who will cancel next month. So originally we could see for the whole year. Now we can see for a specific month. And then from that, we can move into prescriptive analytics and say, okay, we know that Bob is going to cancel. So we will offer Bob a free upgrade for 12 months. And that again could be from some analysis that based on the type of customer that Bob is, then this would be the best way to correct that particular action that Bob will take next month if we offer an upgrade for 12 months. And again, that could be something that you've seen before. You may have seen that in your Amazon Prime, or you may have seen that on Netflix, that because you've watched this movie, we're recommending this movie. And those are some type of filtering that actually is employed. So that's how we evolve AI to BI. Now, we're saying here that we actually will partner with companies here at Fujitsu. We partner with you to basically understand your data. We will basically do consultation to find out what is happening in your business, what is important to you as a company. We do our in-depth understanding, and then we move into our data understanding phase where we would put together different modeling techniques or data preparation, moving from data understanding, where we can build our models out based on the relationships that we've found in the data. So after understanding your data, we can actually start to prepare the modeling techniques or the data mining steps that will build our models. And then it's important to note that we will need to evaluate that model because we understand that in this market that, depending on machines, may be subject to some criticism. So we can set thresholds to make sure that our models are performing at the way that we see fit. And when I say evaluation, we're talking about an accuracy calculation or a stability calculation based on what is actually happening in our data set. And if we've met that threshold, then we can move into deployment, right? So this particular method is what we here at Fujitsu will partner with, various clients who are interested in moving away from traditional methods into AI in their business intelligence campaign. And this process is called the CRISP DM, which some of you may already be acquainted with. Now, it is a situation that we are saying that to actually do this, we recommend a data warehouse, which is Azure Synapse Analytics and Power BI, right? Now, with this particular arrangement, we're saying that there's an average rate of increase of about 271%. And most customers, based on statistics, report on increased customer satisfaction, faster time to insights, and lower total cost of ownership. So this is one of the solutions that we recommend in terms of being able to move from the traditional method into a cloud environment and using that for our BI solution. Now, it's important to point out that there are different use cases that this solution could be implemented within. Now, just to name a few, we can look at classifications. Now, for your company, we know that there are different types of companies. There are different problems that you may need to solve. So we could use AI to possibly predict subscription rates and then roll that out into individual customers who will subscribe based on a particular data set that you have or a combination of different data sets, as well as managing or looking at their risk categories or to do a prediction on their default rate. And that's just a classification way of doing it. If we're going to look at a recommendation method, that could be something more synonymous to what you're seeing on Netflix or what you're seeing in Amazon, where some of these things could be item recommendations like Amazon, or user recommendations where, like Facebook, you see that, because this user, Facebook is recommending another user to you, or market basket analysis, where that's a different form of algorithm that talks about if one item is purchased, the next likely item that will be purchased would be, and that's another form of recommendation engine. Moving into more unstructured data, we can look at possibly sentiment analysis. What this is talking about is more like product lineups. So you could have a new product that's coming out in the market and it's just been launched and you want to know what is happening, what is the general public saying about my product. You could go on your Twitter stream and you could actually load your different text that's coming in from different persons, and you could analyze the polarity is the word, but actually you'd analyze whether or not the feedback is positive or negative, which is subjective or positive, right? And that's a sentiment analysis. And these are just some of the basic use cases that we can actually implement for the Azure Business Intelligence use cases. Now we're going to talk about a little bit, we spoke about the importance, we spoke about the value, we spoke about why it's important, but we now need to talk about how do we get it done. Now I recommended Azure before, and so with this platform, we're now going to talk about some of the resources that you need in order to move into this space. So the first thing we need to talk about is the data warehouse itself. This is where all of your data will be consolidated. So again, you may have your silos, you may have different databases, you may have different branches of companies that have different data sets. What this will do is that it will apply the ability to consolidate your data and be able to scale it in a way that you don't lose efficiency. So even if you had an application before that was using maybe some databases, you can modify or manage the type of compute power that is rolling into your data warehouse. So it could be transactional, that you have a lot of transactions coming in and we need to ingest that and then do our analysis. The cloud platform is equipped to handle these type of transactions or any type of database that you have. It's just a matter of configuring to your needs. The next thing that we need to look at is data orchestration. So we know as well that there is a dynamic environment for different companies, and our partner Microsoft is aware of that. And so the cloud platform is compatible with different data sources, namely relational databases, which would be SQL, various files, which could be like CSV files, JSON files, Parquet files, and non-relational databases. So maybe you have some databases like MongoDB, which is for probably your transactional databases and so on. What Data Factory will do is create the opportunity to connect to your different types of data sources and create a pipeline to connect to the data warehouse. And usually that's a seamless process to ensure that, again, you don't lose any performance when this is being done. So that is essentially how we get to orchestrate the data from the source destination to the destination itself, right? Now we're going to look at Azure machine learning. And again, we look at different types of analysis that can be done through machine learning. We could do time series analysis. An example of that could be maybe you want to predict stocks over time. We could do a regression, which is our classification, talking about linear regression, logistic regression, or you want to predict whether or not someone will subscribe, whether or not someone will cancel, and our classification techniques, right? And again, we can optimize compute power. So your data may be large, you may have a large volume of data, or you may have unstructured data. You can optimize the compute power, and we can deploy your machine learning models in real time. And when I say deploy in real time, I'm talking about delivering these predictions in the cloud environment while your data is being ingested. So that means you'll be able to see what's going on in the data set. We'll talk about that a little bit later on. And then the Power BI. So this is what we're talking about now. So after we've built our model, we can ingest that over in Power BI, and Power BI allows some, some good insights, which would be like multi-purpose view for your reports. So you could possibly view different reports in different formats. You will have access to your dashboards. So that's, again, a combination of different reports. So you may have your AR dashboard, you may have your risk analyst dashboard, and they have their own prediction sets going on, and they're rolling into this dashboard. And then you can actually have paginated reports. Maybe you want to print some of these reports. So we're automating your models. They're coming in, and then you have your paginated reports, and you can actually print out these models instead of having someone go and build out all the different reports and then print them, if that's what your business is doing. And then we have the Power BI app, which combines your related dashboards and reports all into one place, right? And that's, in a nutshell, the main tools that you need to actually implement a solution as to what I'm describing now. And then for Azure Synapse Analytics, we're saying that this is actually compatible with different development tools. So we're saying that based on your environment, it is dynamic enough to accommodate both Python, R, Scala is not mentioned here, but it is compatible with Scala. If you use the Databricks platform, it also can convert your code if we're doing that. Sometimes it may mean that you need to just add some additional coding to actually pull out more important insights from your data. And then we have our different frameworks. And when we say frameworks, we're talking about what type of engine that we need to use to run some of these models. And then we have what platform we're going to type it on, which is if you want to code in Visual Studio or you want to code in a Jupyter Notebook and so on. And then what we support is that based on everything that I've described, at the end of it, if you should approach us, Fujitsu is willing to partner with you, and we can actually do some of these that's listed here in terms of what we could actually provide to you. We could provide, like, perhaps exploratory data analysis supports, real-time predictions, Power BI reports, data centrality and stability via the data warehouse, and support for prediction shifting, right? And those are just some of the things that we support based on everything that we described before. So at this point, I would like to bring your attention to our demo session. I know that you may have some questions now, but we're going to wait until the end where we take those questions and we'll talk about any questions that you may have that we can actually resolve and discuss. So before I take you right into our data set, I need to give you some context. So we have our data set, and this is our source. This is our pretend database that we need to connect to our cloud environment. So we have a MySQL database and a MariaDB database. And from this, we have three tables. We have a profile table, we have a marketing table, and we have a history table. Now, I could describe everything from here, but this is the on-premise environment. So we're going to look at something more intuitive, and we're going to look at the Azure and see how this would be represented in a more intuitive way. So we go to Data Factory, and that's, if you remember, is where we're actually looking at our different data sets, how we connect to the data source. So I just showed you the data source. Now I'm going to show you how we actually connect to that data source. And then, but before that, we're going to talk about what we have in the data source. So let's take a look. We have our two databases. That's the MariaDB that I mentioned before, which has one table, and we have the MySQL, which is two tables. Now, these are relational databases, and that's what our fake companies currently exposed to. That's what they use. Remember, our cloud environment still allows for us to connect to different platforms or different databases, namely NoSQL or maybe blob storage, which could have unstructured data. It still allows you to connect to your data lake, which again could have your data in raw format. So that's what Data Factory is able to do, but we're looking at these relational databases, which is MariaDB and MySQL. So let's take a look at our first table. So this connection is connected to our source, and that table is called marketing, or marketing table. So we click on that to see what's going on with it. So if we load that up, we can actually preview the data within our cloud environment and see the data set from here because we've successfully connected to it. So it's going to preview the data, and then we'll talk about what we're seeing. So let's take a look. We have a table for marketing, and what these columns mean is that we have the user ID, we have contact, and this is actually talking about the contact, how we contacted the customer, as well as the day, the month, the duration of the contact, what type of campaign it was, and that's represented as a number. How much days passed before we contacted the customer, as well as an outcome. So this table is specifically talking about whether or not a customer is going to subscribe to a product. So this column Y is talking about whether or not they would subscribe. In this case, these customers that we're seeing are not subscribing, so that's why we see no, right? So this is their marketing table. The next table that we need to look at would be, let's go back to our connections again. So that we looked at MariaDB, now we're going to look at MySQL. Okay, let's start with the profile table. So if we load that, we can preview data once more. Taking a little bit of time here. Okay, so the profile data set, now this has some pertinent information related to the customer. Again, we have their user ID, and we have their age, we have what kind of job they do, we know their marital status, and we know their educational level. So that's the profile table that the company has for the customer. So the next one that we're going to look at should be the history table. So we already had that before, so let's go on that and we can preview the data. So this again is still from the MySQL database. Now the history table is talking about, you know, what they have or had. So this customer had some default balance. Well, this is the default column. It's talking about whether or not they defaulted on a loan. We have one customer that defaulted. We have the balance, meaning that they had a bank balance or credit balance, whatever the case may be. And then we know if they owned their own home, whether or not they owned it. We say yes if they do, and we say no if they do not, and if they have a loan. So that's basically the three data sets for these customers. Now, there should be around 15,000 rows or 15,000 different customers in this data set. So who wants to actually go through each customer individually? I know that there are many managers who do that, but there's actually a better way to actually approach this problem. So let's take a look at how we're going to look at this. So we have three data sets, and we know that they all have the same user ID. So first we need to consolidate the data. So we connect it to the data sources, and the next step is to actually create them in our data factory. And this is where we have done that. So wherever you see SRC, that's the database that we're connecting from. So SRC is talking about this environment here. And then after that, we're talking about the sink is where we've dumped our data. So all our data is dumped. So we have the profile dump, we have the marketing dump, that's a marketing table, and we have our history dump. So everything from our source destination is now in data factory, which is why we're able to do our preview data here. Now we need to consolidate that into our data warehouse, and I'm going to show that to you. So this is our data warehouse, right? When we connected and we dumped the data, we created those tables, and we have it as our final table as input prediction, right? So this is our final data warehouse as a database. So how did we get to do that? This is how we created a data flow. Now this could have been coded out, but we could actually use another way, an intuitive way to do it. So what we did is that we actually add the profile data here, the profile table, the history table, the marketing table. And then we combine them to produce this final product. So we combined on the user ID, and we have this final product here, which is the input data, right? And that's in a nutshell how we actually get to that final product of having our data warehouse being consolidated, or our source data being consolidated in our data warehouse. And that's in a nutshell how we got to this point. Now, if we take a closer look, we can actually move into how we can now use this output that we have to build our models. So this is where we do that. And this resource is our machine learning resource, right? So in our machine learning model, I'm going to show you an intuitive way, but then we're going to move back into the more efficient way, or the model that produced the higher result. So the intuitive way is to look at the designer model, right? So we have our source data warehouse. So we can look now how we could put together our machine learning model. So first we take the data set and we perform our training by putting in these boxes here. So all we did is drag and drop here. Normally this would be a lot of code, but with this we can actually build out models in real time and in a quick manner, right? Now, at the end of the day, we were able to produce another model called automated ML. This is the important part where I'm going to spend a little bit more time on. So if we look at the model, if we look at the experiment, the system actually ran over a dozen different models to find the best one, and the one at the top is the best model. So if we click on it, we can see the performance. So if we go to details here, or metrics, I should say, we could see that this model produced a 90% accuracy. And what we're talking about is we want this company is predicting whether or not the customer would subscribe. So remember, we spoke about this data set here that we had before, where we had the prediction, or sorry, the whether or not the customer would subscribe, which is here. So after combining all of the data, we want to predict whether or not they subscribe. So we use the same data set that we have here to actually predict whether or not they subscribe. So this is where we build our model using that variable as our prediction level. So the accuracy was 90% accuracy on our model. So what we did, we exposed some of the data to our model, and then we kept some of the data from it so that we could test it. So we used some of the data to actually figure out whether or not our model is performing correctly, and that is what is calculating this 90 that we have here, right? So if we should go to our explanations, it will now prove or show what exactly is predicting, what exactly we're predicting on, or the features that is most important to do the prediction. So let's go here, we have the model, and we can actually look at the explanation in just a second. Okay, here we go. So here we have our feature importance. So based on our model, this is saying that the most important feature to do our prediction is the duration. So again, we had different columns here for the prediction, and it's saying that out of every single customer, the most important variable to determine whether or not they're going to subscribe, which is the Y column here, is dependent on how long we're going to talk to our customer. So for the company, that could mean that perhaps we need to spend more time with our customers. We need to maybe look at the month that we're speaking to our customers, or look at the way that we're contacting our customers. But essentially, we're saying that the most important feature is the duration of how long we speak to the customer, how we contacted them, and what month we're calling. So that is how we know now that our model is telling us some important information as to how we move forward in building up the amount of subscription that we need. So this is just a basic way of representing that, but just to show the subscription prediction now, we have shown how we've gotten to that point. Now we need to produce this in a presentable manner that persons or managers can look at to have an interactive report. And this is an example of a Power BI report that I put together to show how exactly this rolls out. But just before I do, I need to show an important step. So we built our model, and in Power BI, it has this cool feature that I'm going to show you in a second. Right? So in Power BI, when we load our data in, right, it will bring in all the columns that we have. And this is from our data warehouse that I showed you before. And this is our Y column that we have here, right? So this is what we originally got. Now, this data was not exposed to the model that I just showed you before, but we can import the model by transforming the data. So we would have gotten all the columns up to column Y, and then we could actually transform the data. And from here, we could actually import our model. It's taking a few seconds again. All right, here we go. So the transformation data is here. So basically, once you click on import model, you tell it the data that you want to predict on, and then you could just pull down the data from here. And what will happen is that it will run the prediction based on what you trained it on every single column here, and it gives you the subscription class of this column, and the subscription probability are my predictions. So the actual was no, and our prediction is also no, right? And the subscription probability is about 0.69%, right? And we can see, we can actually track that using Power BI to see how well it's predicting and so on. So if it's over 50%, that's when we will have a yes, the customer subscribe. Let's see if I can filter that quickly for you. Okay, let's go to send. Okay, it's taking a while to load. Let's go to sorry, we'll check on the sending just a sec. Okay, so here we have it. The model actually predicted, we can see some errors here. So it predicted a yes, it was actually a no. So it's variable, but again, the model is 90% accurate. So there's 10% of the time it will not predict correctly. So that's the expectation based on the threshold that we set at 90%. Now, this is the final output that we have for our data set here. And we can see the total subscription probability. Let me show you the view in a more intuitive fashion. So here we have it. This is our Power BI dashboard that we generated. So all those columns are rolling up here, and overall in the overall data set that we pull down, we have an 11.64 probability of someone actually subscribing to use the service for the bank or the company that we have, right? And then if we look at some other data or other information regarding the data set, we see that the average subscription probability improves with the duration of the call, as we rightfully said before. So this is saying that the duration of the call was about a few seconds here, and it's actually higher here. The subscription approach is 100%, and the age of the customer that we need to call is between around 30 to 40 years old to actually get the maximum subscription. So we know that these are the customers that we need to actually focus on to get our subscription rates up. So without this analysis, you could have been calling persons who are up to 20 years old or so on. And then we can actually look at different variabilities here where we're seeing subscription probability over the duration of the call again here. So we can see that we have some important insights. And if we look at the loan column, we can see that persons who do have a loan do not subscribe. But if they don't have a loan, they're more likely to subscribe. And this is again from our prediction based on what is happening, right? So that is in a nutshell how we move from ingesting our data, getting that data into our data warehouse, doing our data orchestration to connect to that, and getting it in the data warehouse, and then building our models. And then from our models, we roll that up into our Power BI platform, which we can deploy in a production environment so that business managers can see these important insights that we have here that's talking about subscription probability. And we can see that the duration of the call and the age is of significant importance. And with that, that is actually our presentation regarding business intelligence, AI, and data warehouse using Data Factory to connect our data sources. So at this point, I'm willing to take any questions. Thank you so much for tuning in. So I'll take your questions now. Thank you. Over to you, Chris.
All right, thank you so much, Jermaine, for your presentation. It was very well done. There are questions coming in, but just to remind our attendees, if you do have a question, please go into the question tab and just post your question there, and Jermaine will answer it. Also, I'm going to post a poll. If you would like to schedule a follow-up, you can just indicate by selecting yes in the poll, and then we will contact you after the session. So just to remind you, if you have a question, post it in the question tab. If you want to be contacted, just indicate yes in the poll. All right, so Jermaine, we have a question. I'm gonna put it to you now. The question is, can machine learning algorithms be used to teach an AI to analyze unstructured petroleum data, big data in brackets, in order to predict which blocks or fields have the best potential for successful exploration and production? Where do we begin?
Okay, sure. That's a great question. So again, what it is that for machine learning, you can actually build a model. It would require for that data to be modified. The important part of it is actually to do some pre-analysis before we say that we can actually do a prediction. So it's important to note that there are different layers to the data sets. And when we actually do the preparation, we do a thing called correlation mapping. And that correlation mapping would actually be executed based on which variable, like I showed you before, which variable is most important to the final outcome. And that outcome must be defined. In our example before, we use subscription. So it would mean that we'd have to look at the correlation and see which columns or data points is actually more beneficial to that, and then we use that to build out the model. So it is a possibility. The cloud environment can work with unstructured data. It's just a matter of modeling. So we'd have to do the data mining, pull out the important information, and then from that we can look at the correlation and do some experimental analysis before we give final answer whether or not we're going to get a type of result. And again, that's dependent on the accuracy that we can use to determine the threshold. So there are a couple things to think about.
All right, thank you so much. So our next question is, how can I connect my on-prem databases to the cloud?
Okay, great. So we have a way of doing that. So for on-premise, we actually have a thing called integration runtime, or a self-hosted integration runtime that we use to connect to on-premise sources. If you have the data in like publicly available data sources, then we could use a different integration runtime. So in other words, what Microsoft has done is that they've created different compute nodes that is specialized for publicly available data as versus on-premise data, which in your case would be a self-hosted integration runtime. So we'd connect that, which you'd probably run from your machine and host it there, and then we would be able to connect to our environment, which is in the cloud.
Okay, thank you. Can I add firewalls within the cloud to prevent unauthorized access to data? We know security is a big thing for, especially as it relates to data, your most valuable resource. So this person wants to know, how can they go about protecting it?
Okay, that's actually a very important question, because we know that the GDPR is something that we need to definitely take into account. So maintaining privacy is important. So just to answer that question, though, there are two ways to look at that. We can do the firewall. There is a built-in feature in Azure that we can do publicly available firewalls, which wouldn't help you in your case, but we can actually set up specific IP addresses that is only able to access, that data set or to access your data, or host it basically. So we do have that option, as well as you have additional opportunities of using the Active Directory to regulate who exactly will be able to access your data. So that's in a nutshell how that would work.
All right. So another question is it possible to build the models on premise instead of the cloud?
Yes, that is possible, but we, as I illustrated before, we're recommending that you use a cloud environment for that because it can be done to scale. And we expect that companies that want to grow actually want to use a scalable environment. But yes, you can actually build that on premise where you can actually save your models as a type of file, and then you could load that in different environments to actually do your predictions in real time.
All right. I don't see any more questions coming in. So I'm gonna thank you, Jermaine, for your wonderful presentation today. I think it's very timely, it's insightful, and it's much needed information. And I want to thank our attendees for being with us today. And just to remind you, if you are interested or you have any questions about our solutions, you can contact your account manager. On exit, you will be prompted to complete a survey. You can just indicate there if you have any need for us to contact you, or if you have any further questions. As I said before, the session is recorded and it will be shared with you. Oh, sorry, there is a question coming in. Oh, the person was just saying, well done. Thank you so much. All right, so thank you so much, everyone. Enjoy the rest of your day and take care. Bye.
Okay.